Okay, now let's talk about what we call the specific heat capacity. You need to know this definition for your exam, okay? So what is it? Well, it's the energy required to raise the temperature of 1 kilogram of that material by 1 degree Celsius, okay? So please remember that definition, okay? The clue is two ones, okay? 1 kilogram of that particular substance and its temperature to be raised by 1 degree Celsius, okay? So that's the specific heat capacity of that particular material, and it's the energy required to do that. Okay, so let's now talk about the specific latent heat. So you also need to know this definition for your exam, okay? Specifically, the specific latent heat for fusion is the energy required to change 1 kilogram of a solid into a liquid, okay, without the temperature being changed, okay? So in this case, here we go, this is going to be the specific latent heat of fusion here for this, this solid substance here, okay? Notice the temperature is not changing, but it's the energy required to heat up or to change 1 kilogram of this original solid into a liquid, okay, or vice versa, a liquid into a solid. Vaporization, sorry, of fusion, remember particles being fused together, getting closer together to help you remember that one. And also in terms of vaporization, which is the other one, the latent heat of vaporization is when we change one state of a liquid and it becomes a gas, or vice versa, okay? So it becoming vapor, which is a gas. Okay, so that's the definition for you here. Okay, so please remember that for your exam. So, what is the equation for the specific heat capacity? Well, here we go. The energy transferred is equal to the mass times C, which is the specific heat capacity of that particular substance, times the change in temperature. Okay? So, the change in temperature has got to be in degrees Celsius, the energy transferred in joules, mass is in kilograms, specific heat capacity is joules per kilogram per degree Celsius. Okay? This equation will be given to you in your exam, okay? So, but just make sure again you're comfortable with rearranging it and finding one of the values if they give you the other three. Here is the equation for the specific latent heat. Okay, so here's the energy transferred. It's equal to the mass of that particular substance times that latent heat. Okay, times that specific latent heat. It could be latent heat of fusion or vaporization. Okay, it will be clear in the question, and it will only be one of them. Okay, so specific latent heat units are joules per kilograms, energy transferred is joules, mass is kilograms. So essentially the specific heat capacity of a material is how easy it is to heat up that particular material and its temperature to rise. Okay, so for example, water has got a very high specific heat capacity, so no matter how expensive your water kettle that you buy, okay, it will still take some time to actually heat up that water, okay, as opposed to like a copper wire, okay, you just need to heat it up quite, with a small flame, and you already can feel that it actually its temperature has risen. Okay, so just be aware that different materials have got different values of specific heat capacity, as well as latent heat of fusion and vaporization. So, how do we prevent heat loss when we use thermal insulation? So remember, we can get heat transfer via convection, okay? And essentially, how do we just stop that flow of energy, okay, from a hot gas? Or we can use double glazed windows, because that means we've got a layer of air in between the two glass layers, which means obviously air is a good insulator and we will get less heat being passed between them, okay? So we've got these various items that we can use. We use loft insulations, cavity wall insulation, all using the same principle of having an insulator to sort of prevent that further energy transfer of heat. So the other thing you need to do is be able to describe how to work out the specific heat capacity of a material. Okay. Now, here we go. We've got an immersion heater. So it's essentially going to heat up our material. So here's our material. It could be water or it could be another type of material. We've got our power pack, okay, which is going to supply the energy required for that immersion heater to work. We've got a thermometer here. Now, why are these things important? Okay, so first thing, we're obviously going to measure a temperature change, because if we look at our equation, we need to work out a temperature change. We also need to work out the mass. So we need to measure the original mass of whatever material we're going to be wanting to measure the specific heat capacity of, and we'll obviously use a weighing scale. So if it was water, obviously we'll put it into a beaker and we'll weigh the water inside that beaker. Now the immersion heater will be connected to a joule meter, okay, which is labeled M here, okay, and that joule meter is going to be the energy transferred, okay. So if we're going to describe this, you need to record the mass of the material that you're measuring the specific heat capacity of. You're going to record the initial temperature once you've turned your immersion heater on. After some time, let's say, I don't know, you do it for 10 minutes, you're going to measure its final temperature as well, work out the difference. So that's final temperature minus the initial temperature. Okay, then you also need to record the final reading you get on your joule meter. Okay, so it will be in units of joules, and then you just need to rearrange this equation. So that means the specific heat capacity will equal that energy reading on your joule meter divided by your mass that you've got from your total scale, your digital scales, multiplied by that change in temperature, and that should give you the specific heat capacity of that material. Now, we are dealing with real life situations, and sometimes the specific heat capacity is slightly higher than the actual true value that it should be, okay, and this could be due to heat being lost from the immersion heater to the air. Okay, so notice not all the immersion heater is inside the water, so we've got some energy being transferred to the air. Some of the energy that does get transferred into the water might also be transferred to the glass walls of the beaker, or to the air on the top of it. Okay. So how do we improve this experiment? Well, we can insulate the container a little bit better, so we could add some sort of lid, okay, or we could ensure that the liquid is filled to the top of the beaker, so it does fully cover the immersion heater. And these are common exam questions. Notice it doesn't say do more repeats, okay? So if you said do more repeats, you would not get an accurate reading, okay? So please be very specific. The examiners want you to be specific in actually looking at the experiment. What could you actually do to the experiment to actually give you a better value? Okay, another way to improve this experiment is to use a temperature probe and a data logger. This just reduces human error in reading off a thermometer. Okay, so notice here the 74 and the 75, it's quite ambiguous. So if we used a data logger, look, it tells us exactly, you know, even to a decimal point here, to 1 decimal point, what the temperature is. Okay, so it's more precise, okay, easier to read, obviously, and reduces human error. However, disadvantages would be that thermometers are a lot cheaper, so this set of equipment is quite expensive. Okay. Also, thermometers are easier to handle. This can be quite fiddly. Okay.